Welcome to the After On podcast. I'm your host, Rob Reed, and this is a series of conversations with thinkers, founders, and scientists. Take a little time and stretch out, because these talks are unhurried and meant to bring you to a top percentile understanding of something important. So, whether you're into startups or ideas, a techie or a lit major, take your time, engage your mind, and you'll be glad you did it. Especially this week, when we'll be talking to Stanford immunologist Kari Nadeau. Kari's among the world's leading experts in the mysterious epidemic of food allergies, which now afflict several 100% more people than just a few decades ago. She runs the Sean Parker Center for Allergy and Asthma Research at Stanford. Sean, whose resume famously includes a stint as Facebook's first president, enabled the launch of that center with a $24 million check, in large part out of his enthusiasm for Kari's groundbreaking work. Before we dive into that work, I'd like to quickly welcome those who are new to this show. Each episode of it is built around a sweeping conversation with a world-class thinker, founder, and/or scientist about their domains of knowledge. In the course of this, I try to bring you and myself a serious grounding in something complex and important that we should all probably understand a bit better. If the frontiers of human knowledge and capabilities interest you, please browse the show's archives at after-on.com, or in your favorite podcasting app. You'll find an ever-growing archive of intriguing conversations with some of the top people in robotics, neuroscience, cryptocurrency, drones, augmented reality, synthetic biology, and many other fields. As for today's topic, whether you realize it or not, dozens of people you know are almost surely affected by food allergies. There are as many as 13 million sufferers in the United States alone, and they include almost 10% of American adults, which is remarkable because until quite recently, food allergies were almost exclusively a childhood disorder. But people no longer outgrow these allergies like they used to. Meanwhile, vastly greater numbers of infants and toddlers are developing them. The reasons for this are a matter of great mystery and debate. Now, even if you're one of those rare people who aren't close to any food allergy sufferers, I think you're going to find this interview fascinating. Everyone loves a mystery for one thing, plus our immune systems are among biology's most elegant and complex creations, but they're far from flawless. Allergies are but one of many grim byproducts of immune systems running amok. Others include horrifying neurological disorders, type 1 diabetes, and more. The good news is that our immune systems may also harbor a vast untapped potential to fight off some of humanity's greatest scourges, like cancer and Alzheimer's disease. We'll be exploring the captivating field of immunology in quite a few upcoming episodes, and we'll begin that exploration today with a condition which probably afflicts many of your friends and loved ones, and many of you personally. My talk with Kari Nadeau is a particularly in-depth conversation. The battle report it delivers from the front lines of the food allergy epidemic is very thorough and in no way dumbed down. But it's also fully accessible to non-experts, all thanks to Kari's remarkably engaging communication style. As always, I've also recorded some terrific additional audio, which is available to the 1,000-plus people who make this show possible through their financial support. I'll tell you more about this week's bonus material after our interview with Kari, but if you'd like access to dozens of hours of extra material, which I've now been stockpiling for over a year, head on over to patreon.com/Rob Reed, and Patreon is spelled Patreon, and Reed is REID. Finally, as regular listeners know, I held to a fairly ridiculous standard for the sort of paid sponsorship that I'd accept on this show. This turned out to be an incredibly effective strategy for having no sponsorship or advertising whatsoever for a year and a half, which did not surprise me, and it was worth the wait, because last month this podcast landed its very first sponsor. It's a San Francisco-based venture capital firm called Obvious Ventures, which was co-founded by Ev Williams, who of course also founded or co-founded significant companies including Twitter and Medium.com. Rather than traditional ads, their sponsorship takes the form of interviews conducted by me with really smart people about new science and emerging technologies, which is exactly what I hope you tune into the show to get anyway, so it's a nice fit. Today I'll be talking to an Obvious Ventures investor named Andrew Beebe about one of tech's coolest near-term products. I say this as a certified science fiction author, because the product is flying cars. It's about time, right? Well, now here are the first 2 minutes of that interview. Then we'll have our long and wonderful conversation with Dr. Kari Nadeau. And after that, Andrew and I will talk about flying cars for a couple more minutes. And then some closing comments and even more. I do hope you enjoy this journey, and away we go. So, Andrew, how long have you been a venture capitalist? And before that, how many companies did you start?
4 years as a VC, and I've started 3 companies, 2 of them in the solar space.
What do you expect an air taxi to look like in the year 2025?
Electric, shared, probably 3 to 7 passengers, depending on the vehicle, semi-autonomous with a safety pilot, way quieter than a helicopter, and most importantly, it'll get you from San Francisco to San Jose in about 15 minutes for the price of a high-end Uber.
How do you expect the carbon footprint of air taxis to compare to present-day transportation?
Today, these 7 people are going to be in separate Ubers that are all fossil fuel cars. Compared to that, this is definitely going to have a better carbon footprint.
Now, people have been joking about our lack of flying cars probably since the Jetsons debuted back in the 1960s. What makes you confident that we're finally going to get there?
I spent over a decade in the solar industry, and I watched solar panels drop in cost by a factor of 100. Lithium-ion batteries, for me, are deja vu all over again. They're critical to electric flight, and I see those batteries already going through that same kind of cost reduction.
So how will these new services differ from the helicopter shuttles we currently have, for instance, in New York?
Yeah, there's a great company called Blade, which offers a service to get you from downtown Manhattan out to the airports, usually in the $200 to $400 per trip range.
And it's a pilot in a traditional helicopter.
That's right. Safe, modern, and well-inspected vehicles. However, helicopters are so mechanically complex that when they're operating at full capacity, they have to be torn apart and rebuilt on a monthly basis, and that creates huge operational expenses.
So I wanted to start just by noting that here we are at the Sean Parker Center for Allergy and Asthma Research. Sean is surely known to many of my listeners for his work in the early days of Facebook and Napster. His role in immunology is less known. So I was wondering if you could give us a quick history on how this center came to be.
Sure. Sean is incredible. He's a self-didact, has grown up in the field of computational science, is grasping immunology and moving it forward for cancer immunotherapy and now for allergy and asthma.
I didn't know he was doing cancer immunotherapy as well.
Exactly.
Interesting.
He is in charge of and started PICE, which is the Parker Institute for Cancer Immunotherapy, and it involves institutions around the country. And the Stanford version is smaller, but for allergy and asthma research, he himself suffers as an adult from life-threatening allergies.
And it was adult onset. He didn't grow up with these allergies.
He did grow up with a lot of them.
Oh, he
but
did.
I think the other issues is that they can plague adults as they move forward in their lives. And it's a very scary disease to be eating out in a restaurant. And even though you've told someone that you have X, Y, or Z food allergy, there's still remnants of that food. And so it's been in the news, but Sean has had near fatal reactions to foods almost 13 times that have brought him to the emergency room. And so because of that, I feel like he felt compelled to want to change that. And not just for himself, but also for many others. And because he understood immunology, when I met with him first, he was understandably skeptical about whether or not what we were doing was safe and effective and helping many. And we talked about the basic science of immunology and how our immune system gets stronger over time. And then he became more and more convinced that we were possibly taking the right path by which to study how people can have prevention of allergies as well as potentially cures.
And he then helped the establishment of the center with a very substantial gift. Was it in 2014?
We first started talking in about 2014. The gift was announced in 2015, which we're really thankful for. And that stimulated a lot of other people to come and join us. Sean had thought his gift should have a ripple effect, and in fact it has. Many philanthropists, which we're grateful for, have given so that we can have the resources. And with that, we've now fundraised for Stanford so that we can give back to at least 100 other sites and researchers throughout the country and the globe.
Wow.
And we're really glad about that because Sean also embraced my vision of making sure that it just doesn't stay in one place.
So it sounds like in the run-up to his decision to fund the center, a lot of his conversations were with you personally. You were already at Stanford. And then when the center got started, you've been the director since the very beginning, correct?
Right, exactly.
And it is a gorgeous, sun-drenched, modern space that you have here. How many full-time equivalents are there now in the center?
There are about 60 full-time equivalents now. So that's grown since 5 when we initially started this in 2009. And in 2009, we had a lot of grateful families that started to help enable our funding, as well as the NIH. And with that, we've built up the repertoire of laboratory-based research and now also computational biology. As we study the immune system and how it relates to allergies and asthma, we also need to analyze all that data. And so we also grew a group of incredible individuals to do that, led by Sandra Andorf now. And with that, we also have a clinical research unit. This part of the center, the clinical trial unit, sends us all the samples and all the research data for the lab, and then the computational biologists take it forward. Importantly, we also want to make sure that we have a place that makes all the food in proper order, that's FDA licensed, and that we understand that this is also seen as a drug.
The food that you use to expose people in gentle doses to the allergies that they have. Yeah.
These gentle doses need to be made somewhere so that we're highly accurate about how much we're giving, and that we make sure that every one person gets personalized approach, that if someone's allergic to cashew, shrimp, and milk, they get cashew, shrimp, and milk, and not sesame, peanut, and egg.
Yeah, you can't outsource that. With the precise dosing that I'm sure that you do and the unique combinations that each subject has, you couldn't say, hey, we got a cafeteria down the street. They can help it. No.
First of all, you don't want to take the risk. So you develop people that are incentivized as to the why. Our group of about 60 now is wonderful, and we work well together because I think we're all facing forward on that why. The other part of this is I believe that when we do research as academicians, we need community-based participation. We need to ask people who are suffering from diseases, what are their issues? What do they want to see in the next 5 to 10 years? And so we have this bridge with the community through our PR group, through our community council, to make sure that we have our finger on the pulse, as it were. And then we also work with nonprofit organizations like FAIR, like EAT, to be able to really understand what are the needs of the public. And then we work with the FDA and we work with the NIH.
Well, that's a lot of surface area. And I'd love to start by reviewing just the chilling numbers that document how food allergies have grown over the past few decades.
This is plaguing all of us as to why this is increasing and to what extent this increase is increasing. In the 1940s, you could see that there is this little blip on the radar of people starting to get diagnosed with food allergies. And it's not like our diagnostics have gotten better. It's not like people are getting trained differently. We really think that this is truly increasing in our population due to biology, due to something in our external environments. We also think genetics plays a role. But since the 40s, we saw an increase.
A little increase at first, right?
A little increase. So maybe it was about 0.1% of the population. Then in the 70s, about 0.4% of the population. There was just another little blip in the 70s.
So it's kind of stable for a couple decades, then another blip, which would have seemed big in comparison to what it used to be, but still tiny.
Still tiny, relatively speaking. Then you start seeing another rise in about the 90s. Another blip, but about 0.8%. Then, unfortunately, after about 2000, you see it really rise high. The first really extensive epidemiological data that was published in Pediatrics in 2011 by Ruchi Gupta shows that it was about 8% of the population under the age of 21.
8% under the age of 21, up from 0.1.
Yes, exactly.
So in the entire history of epidemiology, this is a non-contagious disease with somewhat mysterious causes, with an incidence rate that is going through the roof during a time when most public health indicators have been improving dramatically since the 1940s, particularly in countries like the US, where this is particularly a problem. Is there any precedent for this in the history of epidemiology? I mean, the one thing I could think of is obesity, but that's not something with completely obscure roots.
Yeah, we've looked into this, and we, meaning all the investigators in the field, I really defer to my epidemiology colleagues around the globe, Ruchi Gupta, Katie Allen, and others that have been studying this. And we're only as good as our data, so you could say, well, maybe in prior years, people were just underreporting it. But that's hard to explain everything.
80x, literally 8,000% if I'm right.
Yes. So we think that there's something going on in the environment because even now, after the 2000 increase, it's now doubling every 10 years.
So we're currently on a rate of doubling every 10. So we could be at 16% before a decade is gone.
For some allergens, yes. Right now for tree nuts, they're seeing doubling in certain tree nuts. And that's across the United States as well as other parts of the globe. It used to be thought that this was only in Australia, United Kingdom, and the United States, quote unquote, westernized countries. But now we're seeing the rate of increase in China, for example.
Yeah, I was astounded when I looked at the colored map of the globe in one of your PowerPoint presentations. It looks like China's rate basically rounds to us. I think they were 7.7% and we're 8%. So that's already essentially caught up. And then also places like Brazil and elsewhere, right?
That's right. So we used to think, well, people that are living more in areas where there's a lot of parasites, that those people are not going to be getting food allergies to the same extent.
Because their immune system is busy with other stuff or...
Their immune system is stronger or busier. And that's not been the case now. Now we've seen, even over the past 5 years, this rapid increase in countries like Brazil and countries like South Africa. And each country has its own set of food allergens that are ranked. But in general, there's about 8 food allergens that you can commonly see throughout the world. And that's the other puzzling part of this. Why is that?
There are 8 biggies.
The 8 biggies.
And what are they, just so everybody knows?
And so egg, milk, peanut, cashew, walnut, shrimp, to some extent now wheat, and now seeds.
And is soy in there, or is that connected to wheat?
Soy is connected sometimes to peanut because they're legumes. They're related to each other, although I myself have not seen a lot of soy allergies.
Oh.
But soy can sometimes be listed in those top allergens, but mostly because of association with peanut.
Just out of curiosity, where's cranberries on the list?
So when you think about fruit, that's another type of food allergy. Sometimes people can bite into a cherry or a pear or an apple and get tingling in their throat. And we call that oral allergy syndrome because those proteins that the fruits, like cranberries, they can have proteins, but those proteins get digested so quickly that most of the time they don't create bad reactions.
So they're more on the surface.
Exactly. They're more on
the
surface.
sufferer, and they're not overwhelmingly life-threatening or anything
That's
like
right.
that.
Now, some people, when they eat certain fruit, they might get bloated. They might feel like they have a rash around their mouth. And sometimes that's due to the acidity of the fruit, not necessarily the actual allergy. In addition, sometimes people feel sensitivities. So people that get headaches or bloating with foods, that's not a food allergy.
Really?
That's what we usually call a sensitivity.
And is there a completely different biomechanism behind a sensitivity versus an allergy?
It's a great question. There seems to be differences between a sensitivity and an allergy. Allergy, we usually think about the immune system being involved and that every time you get a dose of that particular food, whatever that dose is, you're going to get a very defined response.
A very specifically allergic response with histamines and other things.
Right. And so you activate those histamine pathways, and then that histamine creates certain symptoms like swelling, rashes that itch, not rashes that don't itch, itchy eyes, runny nose, wheezing, sometimes blood pressure changes, and sometimes abdominal pain within 2 to 3 hours, and vomiting. But usually you don't see at all any headache or things like bloating or gassiness. That is really associated with sensitivity. And importantly, it's not associated with anaphylaxis.
Anaphylaxis being the most horrifying end-state stage of an allergic reaction, which can lead to death. These sensitivities don't go down that path. And that's not an immune-related thing. I'm guessing it's a little bit less understood.
You got it. It's less understood. We are trying to understand wheat allergies versus wheat sensitivities, for example. With people that cannot eat a lot of gluten, we're trying to understand in their bodies, what is the difference? What's the chemistry? What's the immunology behind that? Why are people getting bloating? Why are people getting celiac disease? And then some people actually have anaphylaxis to wheat. And a lot of times these two groups, they don't overlap.
Interesting.
So there's got to be something in the immune system. We're trying to understand that better. I don't have all the answers. But when people ask questions about sensitivity versus allergy, it compels me and my colleagues to try to understand this better. So we think we have a better linkage to the immune system changes between food allergy and how someone reacts to it. but not as well with the sensitivities.
Well, there's so much that we know about the immune system in general because it's so essential to so many other conditions, so that's not astonishing. Just to complete the vocabulary here, what about intolerance, lactose intolerance, or celiac strikes me as wheat intolerance? Is that another thing, or is that sort of a flavor or a subset of sensitivity?
That's a great question. It is usually a flavor or a subset of sensitivities. We have sensitivities being the overall umbrella, and then you have food intolerances that are known in the lay literature. And so when you talk about celiac disease, that is very severe and very serious because you actually have an autoimmune attack on your own gut because of your gluten and how your body responds.
So the immune system is involved in celiac.
In celiac, it's involved.
It is.
Absolutely. In lactose intolerance, in alcohol intolerance, that's an enzyme that people are lacking. So they're actually lacking the ability to chew up a sugar that's in milk or the ability to break down alcohol. Each sensitivity now we're finding by dissecting out pathways, we're finding that the mechanism by which someone gets that sensitivity is different.
Yeah.
So hopefully these broad categories will be able to be dissected out to understand each personal reaction and why.
And some of these intolerances are quite widespread within certain populations. I mean, 8% sounds very high, but lactose intolerance in some parts of the world is way higher than that. In fact, it's just the norm.
That's right. And that has to do with genetics. And the interesting part of that is that if you're lacking that enzyme, most people within those ethnicities also lack that enzyme. Whereas in food allergy, we thought for the longest time that someone with food allergies had to have a predisposition. Their family had to have it. But what we're finding now is 75% of the cases that are new onset food allergies don't have any family history whatsoever.
Really? Interesting. Thank you for clarifying all this because even with all the research that I did preparing for our interview, I had thought of celiac as essentially being an allergy, but it's in a different category, clearly.
Yes, that's right.
Now, the other thing, talking about the epidemiology, in addition to the geographic breadth, the other thing that seems to be remarkable is the number of adults who are now being afflicted. In the past, it sounds like food allergies was mainly something associated with childhood and was very, very frequently, in fact, almost always outgrown by the time somebody reached a certain age. But that has ceased to be the case, right?
I think for the longest time, even when I was a fellow back in 2003, I was learning that if someone has a milk or an egg allergy, they have an 80% chance of losing that later on in adulthood. Now, the last sets of data show that that's maybe 50%. So people with the disease have a less likelihood of actually losing it. But in addition, when you actually take adults and ask them, did they have food allergy now, and did you have it during childhood? We were surprised to find out that 50% of the adults reported that they did not have it during childhood. That in fact, they had new onset adult food allergies to foods that they would have been able to take when they were children. We have plenty of stories of patients saying, I could eat shrimp all the time, and then I turned 40, or then I got pregnant, and now I have shrimp allergies. Why is that? More and more work needs to be done in the adult onset food allergy world, and why that is. The work that was recently published by Dr. Gupta and her team shows after interviewing 40,000 adults, they were able to get these numbers of 50% of adults are saying now that they have a doctor's diagnosis of food allergy in adulthood. The fact that adults are now developing food allergies for the first time says something about the environment. Their genetics are the same.
Yeah.
It's the same person.
It is the same person. There's no question about that. And this research that involved the 40,000 interviews, that just came out in January, correct?
Yes, exactly.
It's very, very recent data. And everybody was quite surprised that the overall adult incidence was at 10% in the United States.
10%. And again, I think that that could perhaps be reflective of the fact that less and less people are growing out of their food allergies. But in addition, more and more adults are getting food allergies for the first time.
Which is so strange. I mean, that's the kind of thing that could really ambush you. I mean, that's frightening because if you've had 500 shrimp cocktails throughout your life, and then all of a sudden you're hunkering down to the 501st, you have no reason to think that all of a sudden this thing is going to attack you.
And there are a lot of people with food allergies now, not only in our country, but also in Australia, other countries that even have a higher rate than ours.
Yeah, Australia is a
out
couple
of 8
points. 1 out of
children.
8 children. Wow.
So With that, people need to put guidelines into place. Many countries have guidelines, but even that, it's really becoming a disabling disease on all fronts. It's also disabling to the economy. It costs about $24 billion a year for food allergy care in the U.S.
$24 billion.
Because of the emergency room visits and because of the specialty foods one has to buy. So I think this is a problem that we have to face head on. We need to understand that the only known treatment for an anaphylactic reaction is an injectable epinephrine device. And that's because the epinephrine can work very fast. It gets into the muscle and can stop all that leakage of histamine and all of those other bad factors that were released by the mast cells and the basophils. And it can work in seconds to minutes, but it only works if there's not enough destruction that has already happened. So if you're late with the injectable epinephrine device, if you don't use it in the first minute of a bad reaction that includes wheezing or dizziness or vomiting like 5 times to 6 times. So you don't need to use an injectable device each time you have a reaction, but you have to know when to use it, which is soon after you start developing wheezing, vomiting, or dizziness.
How many people would you guesstimate carry epinephrine pens with them as a matter of course?
Well, I would hope everyone that has a food allergy, about 25 to 30 million, should all carry an injectable epinephrine device, and probably 2, just in case the first one doesn't work, or if you need a second one, if you're not getting better in a minute. But the reality and the questionnaires that were posited throughout the country shows that probably about 30% of people that even had an injectable device didn't use it when they should have.
Wow.
And then in addition, with third-party payer systems and with insurance coverage and with some of the problems with supplies of injectable epinephrine devices, a lot of people don't carry them.
I would just imagine it's a lot less than a quarter or even 10% of the people who should. Am I right in my pessimism?
I think so, but I don't know the exact numbers. And most importantly is that even if one person isn't carrying it or doesn't get access to it, that's one person too many.
They're so small. Couldn't they or shouldn't they be just on premise at restaurants and lots of public places as a matter of course?
That's a great question, Rob. So people have thought about that they should be in the schools, they should be in restaurants. When you think of the state of California, for example, each year about 300,000 reactions to food allergens exist in the first case in schools. So that's why when Obama was president, he signed the injectable device law that allowed schools to be able to carry them.
Allowed, but didn't require.
Didn't require. We would love it to be in restaurants as well. For example, 90,000 food allergy events occur in restaurants each year.
In the U.S.?
In California.
In California alone. Wow. 90,000 in restaurants. And it's like those Heimlich posters are everywhere, right? I'm sure there aren't 90,000 gagging incidents.
Exactly. So this is real. Now, do all those incidences require an injectable epinephrine device? Probably not, but it's important to train everyone. And if you have a public school system and a restaurant system where training for other items is a requirement, training for how to use an injectable epinephrine device and how to identify an allergic reaction is important. I think we could save more lives that way.
I wonder how many fires break out in restaurants in California per year. Intuitively, I'm going to say it's a lot less than 90,000. And every restaurant does, very appropriately, have fire extinguishers everywhere. And they should. I'm not saying that they shouldn't, but these are far more common, potentially lethal situations that come up. And again, it's not like they take up a lot of space.
No, and there are many that are preventable. So to be ready, to be aware, to be educated is important. I'm glad that people are advocating this more. I'm glad that the media and, for example, your show is helping us get the word out there. All of these things hopefully have a ripple effect on making sure people take this disease seriously and are adequately prepared. On the public sector as well, restaurants, schools, universities, public sports events, all these things, we should make sure that those are in the kits or in the rescue administration kits that people have for first aid.
And imagine airplanes as well, particularly airplanes that serve peanuts.
That's right.
Yeah, which are fewer and fewer these days.
That's right. Being responsible and accountable to the fact that this disease is there, and how are we going to adapt to it?
I think an interesting way to get into the biology of this is to perhaps talk about what antibodies do in the immune system when things are going right, when they're not identifying a peanut as an invading commando, but they're rather identifying and neutralizing pathogens.
So we have wonderful sets of proteins in our blood. The immunoglobulin family is a major one. And there are different types of immunoglobulin family members. We've got one, IgG, that represents most of the immunoglobulins. It's the big one. It's the one that fights infections. It's the one that calms our immune system down. It also can be linked to some bad autoimmune diseases.
What does IgG do when they're playing the role of bouncer?
So IgGs, you can think of like a big claw, and they basically bind to either a virus particle or a bacterial particle or a fungal particle and say, wait a minute, you're not supposed to be here. So the arm part of the claw binds to a cell that then chews up the bad thing, like a virus or a bacteria. And we call that endocytosis. They basically eat the bacteria, for example, because the claw has reached out to it, grabbed it, the cell then eats it, and it's gone.
And the presence of the claw is the signal that this thing isn't supposed to be here. And each of these claws are highly specific. Each one of them is tuned to find just one thing, and it goes bumping into stuff in the bloodstream, sometimes perhaps for its entire existence, without bumping into that one thing. But they're hyper specialized, right?
Exactly. You can think of this claw that has a perfect shape to meet whatever it's going to bind to.
A lock and key type of thing.
Amazing lock and key. And our body is so intelligent to be able to make all these different antibodies. And we have loads of antibodies, and we need them. People that are born without antibodies can't survive.
No.
They need to get it externally.
And so when everything's going right, IgG and these other immunoglobulins, some of them are running through the bloodstream just by themselves as kind of freestanding molecules, and then some of them live on the surface of B cells, correct?
That's right. So some of them are arms that are floating out there.
And they're basically a marker. If they find their enemy, they're going to latch on, and then other cells are going to say, oh, look, the claw is here.
Exactly.
And so they're going to come and devour it or kill it or do their
claws,
thing.
they bunch up.
Yep.
But then they can also be attached by their arms to cells. B cells, macrophage, other cells, that then they go along, but they have all these arms sticking out from them.
So a B cell might have lots of claws sticking off. So now that B cell is also capable to identify lots of bad guys.
Exactly.
Yeah.
Dendritic cells. And that's a beautiful part of our system, to be able to be that eloquent with arms that are specific, but with one big cell that recognizes many different proteins at once. So that's great.
And one of these claws is going to be specialized for chickenpox or something I've gotten in the past.
Chickenpox, measles, really important to have these antibodies.
They're also, after they have found their enemy, they and some of the B cells are always in reserve waiting for it to come back, which is how we get immunity, correct?
That's right. In fact, those vaccines, for example, measles, is so important to give to your child, because then when your child is 100 years old, they will have antibodies that they had developed back when that vaccine was given to them when they were 18 months old. So our body has this incredible memory, incredible strength, and the immunoglobulin is part of that strength, but it's essential to be able to fight infections. And sometimes we don't know enough about these immunoglobulins. They also protect us against allergies, we think.
They protect us against allergies.
Mm-hmm.
Interesting.
Because they exist almost at 100-fold higher, sometimes 1,000-fold higher than this other molecule called IgE.
Yes. So IgE is one of 5 categories of immunoglobulin, right? There's A, D, G, M, and E. Did I get it right? Yeah.
Excellent. You've done all your work. You can take your board.
Thank God for Wikipedia.
Exactly.
But IgG is wildly common. IgE is teeny tiny, 0.05%.
0.05, even sometimes less than some people. But most importantly is that we look at IgE. It's the match that lights the fire behind allergy. If you don't have IgE, it's very hard to have allergies, period.
Oh, really?
Rare. Yes.
Interesting. But IgE does have a day job as well. It does stuff with parasites and stuff, or is it really just a bad guy?
In the days when we were infected with parasites, it probably was helpful. We don't know to the extent that it's helpful now. It is kind of a remnant of the past.
Yeah, but the recent past and evolution adjusts very slowly. So we had to worry about parasites not all that long ago.
Exactly.
Yeah,
so for evolution to have changed things now would be quite remarkable.
Yeah.
But nowadays, we look at this IgE molecule and we think, okay, here's this match. It's lighting the fire behind allergies. But the IgG, the immunoglobulin molecules, the other family member, which is in much higher abundance, can be made to cover out and snuff out that fire. Because the cells that have these claws on them, if they have the claw that's IgG and the claw that's IgE, the IgG will send an inhibition signal.
Oh, interesting.
Which is great. That makes sense. But
So
you
it'll
need a
mute
lot
it.
of IgGs. And it's not a perfect system. There are still plenty of people that have high amounts of this IgG and low amounts of IgE, but yet they still have bad allergies. So we don't understand everything, but we do know the immunoglobulins work with each other and then also can basically neutralize the other.
Tell me if I've hit on an accurate understanding. My view is that IgGs run around and they find bad guys like chickenpox and measles. They claw into them. They send the signal, grind this thing up. IgE is basically doing the same thing, but it's confusing peanut protein for the bad guy. And then having found a peanut protein, it latches onto it. Now all of a sudden the peanut protein is ID'd as a bad guy. And then what happens?
So what's interesting is that you have IgGs to foods, but when you do tests for IgGs to foods, those are not food allergies.
So they will cling on to the food, but nothing bad will happen.
Right. We think. That's really important to be able to distinguish what we know and what we're testing. But IgE to a food protein is dangerous. We know that. And initially, we can start to see in the blood little bits of these IgE molecules that are specific to shrimp or cashew. And maybe the person doesn't have a food allergy yet that's clinically relevant. But we need to keep watching those people because maybe they will become food allergic.
So this is very interesting. Much as the IgG, there's going to be a chickenpox specialist and a measles specialist. The IgE also specializes, and you may have the peanut one or the walnut one, or you may have some and not others. But let's use peanut because that's a very common one. Once the peanut IgEs start proliferating in your system, do they expand in number as your allergy grows?
They can expand in number. And the problem is if you get exposed through the skin, if people get peanut dust on their skin or any environmental allergen, we think that if the skin is disrupted and dry and cracking, then those little proteins, sight unseen, can just get right through the skin and then activate our immune system. So that's what, with those random exposures, your immune system starts just saying, okay, I'm going to make a lot of these IgE molecules because something's wrong, something's going on. And it thinks it's helping you, but in fact it's not. But it's a skewed alarmin system because probably way back in evolution, what was happening is we were getting parasites through our skin. But now we're getting food allergens breaking down the skin. And we have this response, which is inappropriate and dysfunctional, but yet it's happening to a lot of kids and a lot of adults. So in the meantime, what happens once this IgE is in your blood, then it binds to peanut, let's say, and that arm binds to and is recognized by these allergy cells. It binds to and talks to a mast cell or an eosinophil or a basophil. And those are allergy cells that can act within a second. And so when this IgE, albeit very low frequency, doesn't matter. It is such a potent signal that it binds to the peanut, rests itself right into the pocket, the mast cell, eosinophil, or basophil, and then that cell bursts. And when it bursts, it releases histamine and chemicals that were probably supposed to be against the parasite and just kill the parasite, make a lot of mucus, get that parasite out of our gut, get them out of our skin. But instead, now mucus, histamine, getting our capillaries in a way that they start to leak. And so when the capillaries leak their fluids, we start to swell. We start to get red. And then we have this itching response because of the histamine.
Wow.
And it was probably a good response when it comes to a bee sting. Like, you know that bee is there, get it out of my skin and get it off. But all of these signals really now are inappropriate.
Well, it's maladaptive at this point.
It's a very maladaptive system.
So again, to give my sort of simplistic understanding of it, I can imagine the body of somebody who has a sensitivity, got some peanut IgE floating around in it. It's inert for now, but in comes some peanut, and it needs to first encounter the peanut to essentially get switched on. Once it's encountered that peanut protein, it's switched on, it goes right to a mast cell or one of these other cells, and then they start releasing all this other stuff. Now, is there also something that happens when the IgE with peanut or just the IgE without peanut starts swarming around the cell that causes the body to make more IgE? Because it feels like the more IgE you have, the more outlandish your reaction is going to be.
That's right. You initially eat that food, you're allergic, the IgE binds to that food, then binds to the cascade in which the mast cell, basophil, eosinophil all react. So they start to release the bad chemicals, the histamines, the bradykinins. They start to get your body to make mucus and to get itchy. Then those signals from those allergy cells boomerang back to the B cells and the T cells, and there's a specific chemical, and not called IL-4.
Interleukin 4, right?
Interleukin 4, exactly.
Yeah.
And the B cell and the T cell have a receptor for that. So when the mast cells get all hyped up and angry, they make more histamine, but also IL-4s, and the B cell then says, oh, I need to make more Ig.
If it happens to be one of the B cells that's running around confusing peanuts for a commando.
Or a naive B cell that never saw peanut before. And the T cells that are teaching the B cell that's naive and in kindergarten says, wait a minute, this signal, now this new T cell is telling me I got to make an IgE molecule to that food. So not only are we getting the memory B cells to make more IgE to peanut, but also new trainees coming up the block that get taught to then make more peanut. So these sporadic instances of exposure are dangerous for our immune system. We know that. But what we also know is if in low doses we start giving the peanut or the dog allergen every day carefully in low doses, that it suppresses the immune system. The immune system starts to get trained to turn off. So these more sporadic incidences, yes, it turns on and proliferates the IgE response. That's bad. That's pathological. But then in addition, you have this alter universe where if you give it every day, if you give it in a certain recommended procedure, like allergy shots, it dampens the immune system's response that's allergic.
Exposure therapy is a fascinating thing we're going to spend a bunch of time on. Just before we pivot into that, I'd love to go through the range of severity of reactions that you see in people. So if I'm right, it's possible to have the IgE floating around in your system, but it doesn't actually get activated. So that's somebody who's maybe pre-allergic or something like that.
Great question. We do know of people that have high amounts of IgE, but it doesn't really bind anything specifically. And we don't quite understand why that IgE is there yet, but hopefully we're going to get some answers. And then you do have some people that have IgE to peanut or shrimp, and yet when they eat those foods, it's very rare, but when they eat them, they don't have reactions. So there's some other active protection going on in their bodies to protect them against that IgE. And those are really interesting to us. We're doing studies on identical twins, for example, where one twin has food allergies, the other one does not. And we're trying to understand what differentiated these two children.
How common is that? If you've got two identical twins and one has it, are the odds overwhelming or middling that the other one will have it?
It's about 40%.
Really?
What we call discordant.
Are discordant.
Exactly. About 60% are concordant.
So about 60%, if I've got peanut allergies, my identical twin is going to have peanut allergies, but there are these 40% exceptions, which is a very high number.
That's right. So that says there's been environmental cues that has changed genetics, or at least your genetic predisposition. Now, concordance, that means they both have food allergies. They don't have to have the same exact food allergies. So usually if you have peanut allergy in one twin, if it's concordant, you'll have egg allergy in the other twin, for example.
Got it.
So we do need to understand this more. We're trying to understand what protects people actively. So having IgE alone is not the sine qua non of food allergy, that's where we know you have your IgE, then you're going to get your food allergy. And that's the problem.
Yeah.
Because our only CLIA-approved test that we use in the clinic is that IgE blood test. And so we use the IgE, but sometimes it's not helpful. Sometimes people come with sheets and sheets of all this testing, and it says high IgE level, but you don't really know if that person's going to have a reaction or not. So the test in and of itself is not perfect. So unfortunately, the only diagnostic we have now is to actually expose them to the item that they're allergic to and then to say, oh, yeah, you're allergic. Look at your body. Now
wow, I'm jabbing you with an epinephrine pen because you're an anaphylaxis. I'm going to say you're allergic to peanuts. Now, this gets to the most mysterious thing about this epidemic, which is the multifactorial nature of allergy.
When you look at people with food allergies, a lot of people, 40% or higher, have more than one food allergy. It's just that proclivity of having one food allergy allows your body to have another one.
Yeah.
And it could be sometimes later in life. So that's one problem. But the other issue is that usually people with food allergies have other allergic diseases like allergic rhinitis to pollens, or major allergies to bee stings, or asthma, or they have eczema. And we call sometimes this linkage of all these allergic diseases the atopic march, because usually babies, they don't have sneezing and allergic rhinitis and itchy eyes. They start having eczema. You start seeing broken down skin and dry skin and itchy skin when they're infants. Then maybe in about 2 years, you start seeing itchy eyes, itchy nose, and a food allergy. Then after that, maybe when they're 5 or 6, they start getting wheezing and allergies to things in the environment. So in general, even if you don't have the march, these allergic symptoms tend to go together. For example, in our groups that we treat at Stanford, we know that 70% of people that come into our research trials will have other allergies. And in fact, we embrace that complexity because we want to take care of that whole person, not just one area of their allergy. So it is true, it is multifactorial. We need to understand why it might be through exposure in the skin, that all these things are getting exposed through any child's skin, and that activates the immune system so that the immune system starts to become allergic to animals and food. And it's not until we see the symptoms when they start getting exposed to these things later in life. But early in life, that first year of life, we think, is really critical to these exposures of multi-factors. But then there's plenty of adults that they say, I never had allergies to dogs, and then I just started out having an allergy to dogs. So this atopic march doesn't work for everyone.
And then when you have this 8,000% increase in the incidence rate over the span of about 2 generations, it seems when I started researching this, I felt like, well, there's competing theories for this incredible surge. But the more I got into it, it kind of seemed that maybe they're all right and they're all interacting with each other. And maybe 2 or 3 of the factors are important in one person and 1 or 2 are in another one.
My colleague, Katie Allen, she's the one who's dissecting a lot of the epidemiology work behind why the rise of food allergies is occurring. She calls them the Ds. So for the hygiene hypothesis, that's about dirt. That's about saying maybe we're so clean that our immune system forgot about getting exposed to good bacteria in our guts, good bacteria around our house, exposure with animals that we were meant to be evolving with.
So we've kind of become wimpy and soft in our modern era.
I'm going to give you examples of things that we know from epidemiological evidence that there's associations. For example, when the Berlin Wall came down and East and West Germany emerged, they noticed that the people in East Germany that had been working more on farms, that had been having more agrarian lifestyle, had less asthma and allergies than the western part of Germany, which were mostly city. And so then they started these hypotheses about dirt, pollution not being good, activating allergies. We know that smoke and tobacco smoke in particular can increase your rates of allergies and asthma by about 4-fold. But we know that there's some good dirt. We know that getting exposed to dogs, the second D, early in life, maybe the first year of life, decreases your risk. So getting slobbered all over, perhaps by your dog, helps. So good dirt, not bad dirt. We don't want people to go back in time and get exposed to tetanus toxin.
Yeah, botulism.
We don't want people to not have vaccines. Vaccines have not been associated with any allergic or asthma proclivity at all. So being clean is a good thing. Using antibiotics when you need to use them, using vaccines is key. Not getting exposed to tetanus is key. But
having a dog, eating the right fibers, getting your gut in a good shape where good bacteria can grow in it is important to reduce the risk of allergies. So there might be a microbiome link as well?
Very much a microbiome link, we think, but we don't know all the answers to that yet. So I couldn't tell you today, this is the microbiome to take to be able to cure or prevent your food allergies. But we know that having good microbiome is important.
So that is a factor in the multi-factors and
One
perhaps,
factor. That's right. Dirt, dogs, now dry skin. We know that dry skin, and perhaps due to a lot of detergents that we have in our society, we were very clean and we like to use detergents on all our clothes. But unfortunately, it's possible that because of that, a lot of the skin is breaking down in our infants more than it should be. And that if we don't protect the skin enough, we will get cracks in the skin. And by exposing allergens through the skin, that will activate the immune system to become maladaptive.
Yeah, you'd mentioned that sometimes eczema is the first sign on an infant, and that leads to other things.
That's right.
Yeah.
And then vitamin D, another D. For example, Dr. Allen's research in Australia, where they don't have any supplementation for vitamin D in any of their food, and they slip, slap, slop to take care of skin cancer prevention, their levels of vitamin D were very low in Australia. And Katie and her colleagues think that that's one of the reasons why their increase in food allergy in Australia.
I lived there when I was a kid. And even back then when I was a kid, despite the sunshine, which is normally very preventative for vitamin D, if you're really, really diligent, as you should be, about sunscreen, suddenly your body's not making it naturally. Now, I know that when people have vitamin D deficiency, there's some debate about whether supplementing is actually going to do any good, or if you just really need to put your body into a position to make vitamin D. And for those who don't know, exposure to sunshine does cause the creation of serum vitamin D inside the body.
Exactly. You can convert it. But again, we have to be careful of sunshine. So, yeah, the big question is, because the epidemiological evidence in Australia, at least, showing that by not having enough vitamin D, that was associated with increased food allergy risk, then how do you compensate for that? Well, external vitamin D supplements might do that, although there's controversy. Carlos Camargo at the Mass General is also looking into this. And so the last D, though, is diet. And that diversifying the diet is probably something we should be doing in infancy early on and often.
Yeah. Let's talk about this, because this was the self-inflicted thing that probably has a lot to do with the surge in the 2000s. We talk about some of the national guidelines that started spreading on this topic.
When I was getting trained as a postdoc plus a clinical fellow, we were all getting taught, avoid, avoid, avoid. This is some kind of epidemic. It's coming up since the 40s, the 70s, the 90s. And so what's going on here? Why are we seeing this increase in food allergies? And people were puzzled. People saw that people were anaphylaxing. Not any infants or toddlers, but still it was happening in childhood. People were getting exposed in school. And so people got together in guidelines, very well-meaning, very well-trained physicians and scientists, to be able to get together guidelines to say, how do we stop this seeming epidemic?
Yeah, what was the tip of the iceberg at that point from what
Right.
you said? And they put the iceberg in the freezer rather than in the microwave, it sounds like. So what happened? What were these guidelines?
So the guidelines said delay the introduction of foods like peanut, egg, milk, as well as shrimp.
Delay it to children, to
2
newborns.
to 3 years of age. That's right. Don't feed it to your children until they're 2 or 3 years of age.
With the logic being that the immune system is better formed by that time and they'll be readier for it? Or was this just a
Exactly.
guess? Like, how in the world did this happen, right? There hadn't been any double-blind study or anything like this, but these literally did become national guidelines that responsible parents or obsessive parents, maybe even more responsible than responsible, would look up and say, oh, wow, okay, no peanut, egg, walnut for my child until they're, 3?
That's right. International guidelines then became available in most countries to say delay, delay, delay.
And consensus formed on this. And these guidelines are not easily passed. So overwhelming consensus formed. And again, I'm sorry to be harping on this, but there was no data. This was just a hypothesis. Is that common? Somebody must have felt really sure.
So there was no randomized control trial. People were using this as a precautionary reflex, and I wasn't there, so it's hard for me.
You were still being taught at that point.
I think we thought that by not exposing those B cells, by not training them to make that IgE early, maybe you could just quiet them down. So that was kind of the going thought. It was also that if people did have any B cell that was starting to make IgE, that by not giving that food,
not feeding it,
you weren't going to continually expose it and get it revved up. But unfortunately, it was probably coming through the skin. So long story short, these guidelines were made across the world. There were some countries that didn't pay attention to them. So those are the countries now that have the lowest rates of food allergy.
Denmark was one, right?
Denmark,
Yeah.
Norway. But nevertheless, so these guidelines were made. A whole food industry became arm in arm with these guidelines. You have many companies that started to write stage 0, stage 1, stage 2 type food products.
There were foods that were being released and probably selling in the volumes of billions of dollars that were supporting this well-meaning but erroneous medical view.
Exactly.
Yeah.
And then to answer your question, how often does that happen? It probably happens more often than we would ever want.
Yeah.
That when you think about guidelines, when you think of HIV and HTLV and Robert Gallo and the French investigator that was studying AIDS, 10 years went by before people actually said, this is the virus that causes HIV.
What's worse about this is this seems to be magnification. So you had said that one of the D's is diet, and we feel very high confidence now. The recommendation is expose them as early as possible, right? So we ended up doing the literal opposite of what we should have done. What it reminds me of, in a way, is the opioid epidemic on a different level, because there, on essentially zero data, this orthodoxy took root, that pain was under-medicated, and that opioid painkillers almost never caused addiction. So that idea got out there, and once it took root, that orthodoxy became extremely hard to expunge. And that stuck us with this vast problem of our own making. Now, the difference is the opiate story has some real villains who knew what was going on and were profiteering from that. I don't think there's any ringleader in this case.
No,
right?
there's no ringleader. It was kind of benign negligence that there wasn't really enough data to say anything otherwise. But then, come 2008, come some studies that were coming out of Australia in epidemiological evidence saying, well, wait a minute, the children that actually start to eat egg early, they're not getting the allergies. And there was another study in Israel where, wait a minute, the kids that are starting eating milk early, they're not getting as many milk allergies. Same thing in Japan. They started publishing this data saying, wait a minute, guys, we might be wrong here.
And this is 2008, 2009.
2008, 2009, 2010. These studies start to come out of the international literature.
So the orthodoxy's been in place for about a decade or something like that. Yeah.
Then 2011, some guidelines start to come out saying, well, wait a minute, you probably shouldn't delay.
Some national guidelines got withdrawn.
Exactly. 2011, they're starting to kind of say, well, wait a minute, we might be wrong. Then Gideon Lack is visiting Israel in an audience of Israeli physicians, and he says, please raise your hand if you are seeing a lot of peanut allergy in Israel. And he always asks this before he starts lecturing on peanut allergy, which is a problem in the United Kingdom. And so that's what he's lecturing on. No one raises their hands.
So he's walking the earth, and this is a standard opening thing.
Exactly.
And in his note cards, it says, look at forest of hands, say, yes, I'm not surprised. And to his astonishment, here he is in Israel and no hands going up.
Right, because in the U.S., they would be up. In Australia, they would be up. But then Israel, very few people raised their hands at all. And so he thought something must be going on here. And then he realized that the kids were eating bamba early and often.
Is that a snack that has peanut butter?
It's a peanut flour snack that a lot of the kids eat when they're infants in Israel.
I want some. Peanut and peanut butter is my favorite food. So thank you for all that you're doing to keep this terrible scourge from striking me down, because it makes life worth living. So
well, keep eating, because it's important
I will.
to keep toning your immune system, because we think through the skin, allergies begin. Through the diet, allergies can potentially stay quiet. The dual allergy hypothesis, we call it, where we think that for a number of people, they probably got their allergies through the skin. Now, not everyone, there's always exceptions, and that if you tolerize through the gut, because the gut immune system is meant to be educated. We have 70% of our immune system around our gut, and the gut immune system gets the most educated the fastest of all the organs on our body by the first year in life.
So peanut butter wrestling is probably a bad idea for anybody
with eczema.
But general peanut butter wrestling is something that should never exist, and I don't think it does, so that's good. Isn't there also some talk about epigenetics?
Sure. So when we think about epigenetics, you can think about it as music. And our DNA is like the notes on a page. They're there. They're going to be read. That is on the page, something that you can copy, and you're going to see those notes.
You got this catalog of music in your cells. There it is.
And that DNA is important to have in each cell. But how you play that DNA, how fast you play it, how slow you play it, whether or not you play it at all, those are the epigenetic, the added influences as to, are you going to play these notes or not? And so that's kind of like a coda or a forte. And so in the same regard, we have our body epigenetically on top of the genetics. We have this other way of controlling our genes, which is exquisitely modified by our environment, by viruses, by chemicals, by tobacco smoke, by vitamins. And so with all of this, we are now learning that the environment plays a really important role on our genes.
In terms of what gets switched on. So I may well have a peanut allergy gene sitting somewhere in my genome, but if I don't get exposed to I don't know, a certain bad TV show that switches it on. Obviously, it's not that. But if I don't get exposed to some environmental toxin or stress, it may never express. But the other thing that's crazy about it is the switched onness of a gene can be hereditary. And so I think what I'd read is there's evidence that having a parent or grandparent who smoked, even if the kid was never exposed to the smoking, is a risk factor in food allergies. Am I correct about that?
Yes, that's correct. So why is that? We have two different types of cells in our body. Cells that we call somatic cells, that are our body cells. We inherited the DNA from our parents as well as our grandparents. And then we have germline cells that actually get passed directly, sperm and oocyte. They get put together to make the new baby. But when that happens, the germline DNA can have marks that were made by the environmental exposures by the grandparent.
It comes into the baby saying, hey, I am gene X and I am switched on.
Exactly.
Whereas gene X might come in and say, hey, I'm gene X and I'm not switched on because my grandfather didn't smoke.
Exactly. Or my grandfather didn't go through starvation in World War II.
Yeah, stresses and things like that. It's amazing how many things jump generations. And it almost feels Lamarckist, right? Like,
absolutely. So,
yeah.
We're, of course, as scientists, we understand Darwinian evolution. That's really important. But Lamarckian evolution, it's possibly there. Like, I know a lot of people made fun of Lamarck over time.
Everybody did.
Here we now have a reason behind some of the thinking that environment played such an important role that, for example, when we look at dog evolution and there are certain domestication of foxes, for example, that is happening much faster than anyone would believe.
And this is one of the things that's here, it seems, in
That's
allergies.
Right. So now let's talk about allergies. They found that if people got allergen immunotherapy while they were pregnant, their babies did better.
Allergy immunotherapy. Like oral immunotherapy or some like injections?
Allergy shots.
They're babies. Well, that makes sense too because the baby's also environmental exposure. They're in the placenta. They're sharing some blood. Yeah,
exactly. So that's one study. But now let's take it one step further. What if the mother during teenagerhood, before she even got pregnant, had allergy immunotherapy shots?
That's interesting. That carries through?
People have studied those people and whether or not their children have less likelihood of allergies, and that was published. And yes, that's true. To a certain degree, it's not like a huge epidemiological database right now, but I think we need to keep watching this.
There is signal there.
That therapy could perhaps change your genetics to a good degree.
And benefit your children.
Wow. So we need to understand more about how epigenetics is taken through generations. But even if anyone's for their lifetime on Earth, we know that epigenetics does play a role in their own health.
Yeah.
And we need to get better at understanding how that occurs. Modifying the DNA sometimes can be a good thing, sometimes can be a bad thing. So we need to understand each relationship there. But in terms of food allergy, we do know that smoking, for example, can, what we say, methylate your genes in not a good way and can induce asthma genes, can induce allergy genes, cannot be good for the microbiome, for example, and can turn off certain genes that we need to have to protect against food allergy. So there's a lot of things going on. Epigenetic marks, though, are nice to use as biomarkers to decide whether or not someone is going to be allergic or not, or if someone's going to respond to therapy or not. Epigenetics, for example, was used in an article from an Australian colleague to diagnose food allergies.
Wow.
So I think we're going to get there. I think epigenetics needs to be part of our conversation now. And I think the public should demand more in terms of doing research on these marks to understand the changes between the environment and the genes.
I'd like to take a brief detour and talk about your own engagement with and interest in the field and where it came from.
So when I was growing up, I had terrible asthma, and I'll never forget when I was 4 to 5 of literally not being able to breathe and just feeling short of breath. And I'm not the only one that's had these issues. A lot of kids and adults have that same feeling of not being able to get your breath in.
So environmental allergies in your case as opposed to food allergies, but you had that pretty bad as a very young child, it sounds like.
Exactly. And so I was growing up on a houseboat and also had lots of moisture. And because of that, we have a lot of mold, and I was allergic to molds. And so what was great, though, is that when I got out of the mold, environment.
So you moved out of the houseboat and you became a landlubber.
Exactly. And
you became a landlubber, yeah.
And we moved into a place without a lot of mold. My asthma got better. So that was nice. So not being exposed to these things was good. But importantly, I also found out that I could grow out of my asthma. Now, that was very lucky. But when I look back and think about those anxiety movements that led to catalyzing me wanting to make sure that no one else would have to suffer through that, because it is extremely anxiety.
I can imagine how terrifying it would be.
And as a resident, as a fellow, I saw people die of asthma, even due to cat allergies, for example, that still happens. 250,000 people die around the world each year due to asthma, and that's rising because of pollution and other exposures now. So these diseases are very common. 1 out of every 3 people has allergies on our planet at some point in their life.
Allergies of some kind.
Allergies of some kind.
I assume then if we're just getting into the point where it's 8-10% with food, that environmental allergies are more common. Is it also IgE that's messing us up? So IgE's to blame for pollen as well?
For most, exactly.
Thanks for all the good work with, the parasites back in the day, IgE. I'm glad you saved my great-grandfather, but man, they're messing us up on all kinds of levels.
But nevertheless, I think we can get ahead of this. I think there is a lot of hope and promise.
And so when you got into medical school, that was just a natural area of interest because of your background. And then when you got into immunology, did you think that you were heading toward food allergies at that point?
When I was a fellow and as a medical student, I saw people anaphylaxed to chemotherapy, to drugs, to things that they should not have had a response to the point where they couldn't take these life-saving therapies. And it bothered me. I initially did oncology, in which these chemotherapy agents would wreak havoc on the body, and then people would have allergic reactions to them, and they would no longer.
It wasn't just the bad stuff of chemo, which is plenty. There were actual allergic responses.
Allergic reactions to this chemo. That is the only thing that's keeping that child alive due to their leukemia or X, Y, and Z. And so, unfortunately, I saw people not be able to get appropriate medications because they had allergies to them. And that bothered me. And then I became a fellow and was very lucky to have wonderful mentorship along the way. And I loved what I did my PhD in, which was biochemistry, and that we'd studied the biochemistry of the immune system and parasites. And I asked my advisor, what's the most complex, complicated, challenging field there is? And this is in the 90s. And they said immunology. So I said, all right, then I should study it and put all this in some sort of understanding. Now, immunology is complex. It's changing every day. You have to keep really on top of things. And it's not unlike other fields. But in the meantime, I really liked immunology. I wanted to understand the aspect of tolerance and how people become tolerant to things. For example, a kidney transplant. Or how do they become tolerant to food?
I've been interested in that since I first watched Princess Bride.
There you go. Exactly.
That guy made himself immune to the poison.
Exactly. Alexander the Great did it. So these are common things, and people in the rainforest have been doing it for centuries, where you eat little bits of the leaf to be able to train your immune system not to become allergic to that plant.
I didn't know that was an indigenous practice. That's interesting. So that goes way back.
So this is kind of a natural item that our great-grandparents probably did and knew to do. But nevertheless, how do we put it into action and explore it as a therapy and use it to train the immune system in a good way? Because these epidemics are rising. We need to think about how to prevent them, but also how do we stem the tide by treating it?
I'm sorry to summon a bad memory, but in an earlier conversation, you told me about a terrible situation. I think you might have been a resident when you had to deal with a father who literally lost his child to an allergic reaction to a glass of milk.
Yep, exactly. So what happened was I got very interested in immunology because of the complexities. I began to study it through immunodeficiencies in people that became tolerant or people that lost that tolerance. There were certain genetic diseases that actually led to having someone with a lot of allergies, more so than anyone else. Really bad food allergies. And so I started to be interested in this food allergy problem out of people that had what we call immunodeficiencies, genetic defects in their immune system. And then, my second year of fellowship, I was called to the intensive care unit because a child had been unfortunately diagnosed as brain dead because they had drank their sister's glass of milk accidentally, and they had a milk allergy.
They had a known milk allergy, but this was a young child and didn't know not to drink the milk.
Poor parent, took out the EpiPen and just was shaking with his hands, and I'll never forget him saying, why didn't this work? Why didn't this work? And unfortunately, it had been expired for 5 years, and they hadn't gone to see an allergist again. And they were told that, yes, the child could grow out of milk, but you have to go back to an allergist to double check. And the parents didn't. And it's not the parents' fault. A lot of people don't. They get busy. So we need better diagnostics.
And this was early before we understood things as well as we do now. So this man lost his child.
Lost his child. Now that child became a liver donor. And I take care of the recipient, who also now has a milk allergy.
Wow.
So when that whole story unfolded, and because I had worked in biotech and learned about how to do clinical trials, and because I had a wonderful mentor here, Dale Umetsu, who had been working on food allergy already.
Here at Stanford. You're already at Stanford.
In animal models, and Steve Galley, who'd done some animal models too. I thought, let's put two and two together. This is a high unmet need. If you got trained to understand immunology and got trained to learn how to do clinical trials and have training in how to run mechanistic work, this should be something you should look into more. So we developed a first trial, worked with the FDA, got that approved, did a small study, and that worked well.
This was a trial for oral immunotherapy?
Oral immunotherapy with milk using Xolair, because I had really wanted to help milk out initially.
So let's talk about oral immunotherapy, just to sort of backfill that detail. That is sort of the Princess Bride thing, and we've talked about it a little bit, but just a quick pocket definition for folks to know what this field is and how it works.
So oral immunotherapy was started a long time ago. The first publication, and it was actually in Lancet 100 years ago, where a doctor started giving a little bit of egg to a child that was egg allergic in small amounts over time. And in the thinking that if you give it to the child and their immune system grows stronger, that they could get desensitized. And that was 100 years ago. They didn't even know about IG and all the molecules. IG was just discovered about 50 years ago. So, but it worked. That was one patient. And so people started to think about, well, we were giving immunotherapy to environmental allergens. Why not food?
So increasing exposure, that was already being done with injections and so forth for people who were allergic to pollen and bees and stuff like that. So that already existed.
It already existed. That's been also going on for about 100 years.
That long?
Yes. But now food comes into play. And then the question is, when did that really start? Well, the first publication for milk came out of Europe because in Italy and Spain, they started seeing milk allergies. And so they started giving children very small amounts of liquid milk in higher and higher doses so that they could decrease their milk allergies. But they didn't control for that study. So the first control study actually happened in Johns Hopkins, where they actually did a placebo control, and they tested milk immunotherapy. First, you start with tiny milligrams amount of milk protein, and then you increase it to about 1,000 milligrams in children that are highly allergic to milk. And you train their immune system every day. It cannot be done every week. It can't be done every other day. You need to do it every day and get up to high enough doses so that you can cross the Rubicon, get up to a plateau where once you get up to that maintenance dose every day, then the person has a lower threshold for reaction.
When was that Johns Hopkins study done?
I think that was done in 2008.
Wow. So 90 years after that first Lancet article. So that was the first sign that there is something here. Could you describe how OIT, it's often referred to as OIT, right? Oral immunotherapy.
Exactly, oral immunotherapy.
Could you explain or describe how that unfolds for somebody who's experiencing it in a clinic now? Because there are dozens, even hundreds of clinics now that do this for people. Yeah.
So each oral immunotherapy, it means that you're ingesting the food item, and people have been doing this, again, for about a century. But foods you have to be extremely careful about because there's a higher chance of anaphylaxis. So you never want to do this at home. And importantly, always have a supervising physician if you are thinking about this, and have a bunch of questions for any clinic who's doing it. But oral immunotherapy, or OIT, now is occurring for milk, peanut. The first peanut investigations occurred for OIT in Arkansas and Duke, for example, and those were published in 2009. So these are all relatively
really, really new.
Not very mature fields.
So if somebody takes their kid into one of these clinics, what happens? What unfolds?
You should know that it's still experimental, but the FDA is looking at companies that are trying to get products approved in this area for peanuts specifically now. But there's oral immunotherapy, there's epicutaneous immunotherapy through the skin. So now if you were to go into
and sublingual clinic, as well, right?
And sublingual, exactly. So we call it OIT epicutaneous immunotherapy, and sublingual immunotherapy, SLIT. And we still need to figure out how well SLIT is working. But
they're all variations on the same theme, right?
Exactly.
Yeah.
So if you walk into a clinic that's doing it now, and you're going to ask a lot of questions about quality of work and knowing that it's experimental, carrying your injectable epinephrine device at all times, once they diagnose you with that food allergy, then you start taking a little bit of that food in small amounts, but you got to have it be done very safely.
So you go to the clinic every day, or you go to the clinic?
Go to the clinic every 2 weeks to updose. So you'd go get a dose, and then you'd dose it every day at home.
And it starts as small as a millionth of a peanut for sublingual, I heard. Like,
Yes.
it's literally, these are
Very
tiny.
small amounts.
A millionth of a peanut.
That's right.
The first day is grim, right? Because you have to be there and they keep cranking it up to see where your threshold is. Am I right?
Most clinics will do a food challenge. You're
That's what
right,
it's called, food
Rob.
challenge. Okay,
Exactly.
yeah.
Some clinics don't, so it really depends. We're trying to create a system where you might not need a food challenge anymore. And I don't work in these outpatient clinics, but from what I understand, what happens is they take a history, they will do blood tests, they'll do skin tests, they'll understand to what degree you want to get desensitized, they'll tell you about the safety issues, they'll tell you that it's experimental, it's not approved officially yet. But importantly is you will start with potentially a millionth on the skin or underneath your tongue. Over time, you build up your immune strength to change your threshold for reactivity.
And the food challenge at the beginning of it, they find out there might be somebody whose threshold is really 1 in 10,000. And if you start
Right.
them at a millionth, you're just going to add several months to their treatment unnecessarily. So the food challenge is several hours on one day.
Yes, but what you don't do is whatever you could get up to on that food challenge, that's not the dose that you go home on. Because oftentimes people can start having problems with that dose. They might have been able to get up that high, but then the next day they don't do so well. So you want to really start small and build up. And so most clinics are going to be extremely cautious and conservative. And you want to make sure that whoever you're talking to has done this before and has a lot of experience with how to help you. And there's a lot of anxiety around this, and appropriately so. And I think that people should know that there are reactions along the way. And so that's where someone like myself and our teams at Stanford and other institutions are trying to think about, okay, there's oral immunotherapy out there that's happening. There needs to be an approved FDA product. Terrific. Let's do that. The epicutaneous therapy is happening. There needs to be an approved product. Great. That's moving forward. I'm so glad patients will have choices. Sublingual immunotherapy is something that hopefully will move forward too within the FDA approval process. But that's kind of the first stage, right? How do we make it safer? How do we make sure that people that just don't have peanut allergies, but maybe other allergies, also get helped? How do we make sure that this is going to be a therapy that's used in adults and kids? So great. We accomplished a lot over the past 20 years, but now we've got to worry about safety, making sure people have an overall wellness approach, making sure that we don't cause any additional allergies, making sure that we don't induce gut reactions like eosinophilic esophagitis. So all these things now are in our checklist for, okay, how do we improve? This therapy is working for the majority of people, but the side effects are there. And so how can we even do better? So I think there's biologics coming up like the anti-IgE omalizumab, which is called Xolair. There's dupilumab, which is this anti-IL-4, interleukin-4 biologic that's coming out. There's another molecule called anti-IL-33. So there's a lot of excitement around molecules that could be used as sandwiches with OIT to make it safer.
Let's talk about the work that you've done. You've been very involved in this Xolair, and also you've been very involved in introducing OIT to people who have multiple allergies. That was something that simply wasn't done previously.
So I feel very lucky that I was mentored by people that had already been doing this. For peanut, for example, Wes Burks and Hugh Sampson, and then Dale Umetsu, who we initially did milk because I was compelled to try to help milk allergies because I had seen that poor boy die of milk allergies. And then we started to use Xolair with the milk because we wanted to go higher on the milk than milk immunotherapy had done before, because most people at the end of the day with milk, they could be exposed to high amounts of protein. The average smoothie, for example, has 16 grams of milk protein. A pizza. We had one of our first patients who, when I said, what are your goals? Again, like my goals are your goals. We want to make sure that if a person's going to start doing oral immunotherapy, that what we end up with at the end of the game is something they want to achieve. So I said, what's your goal? And he said, I want to eat a whole pizza and
so that's
not
a
react.
lot of grams. Yeah.
So especially with milk, we had to go up higher.
Go up higher, you mean get to a higher level of tolerance?
Higher level of protein, whereas a peanut, one peanut is about 300 milligrams. And most people, unlike you perhaps, don't really want to eat a whole peanut butter and jelly sandwich. They're happy with just eating a peanut.
I don't want the jelly anywhere near it. I'm all about the peanut butter, but
fine.
I'm lunatic fringe on that. So what is Xolair, and how did you come onto that as being something that might be an accelerant for this OIT therapy?
Anti-IgE basically quenches that IgE, that match that lights the fire. So the anti-IgE is basically going to just blow it out.
Is that a name of an actual substance, or is that a generic name for things that can stomp it out?
Right. It's the generic name for anti-IgE monoclonal antibody.
Okay.
The only anti-IgE monoclonal antibody that's currently out there for commercial use is Xolair.
Is Xolair. Okay, so that was already out there.
Yeah, it was already being used in asthma.
So it's something that basically gets into the body and comes across an IgE and says, hey, you know what? You're not going to claw into a peanut thing. You're going to claw into me.
Right. And so it was being used, it's a shot, it's subcutaneous. It was already being used in asthma. It had a good effect. It had been used already by my colleague Tom Casale for use with allergen immunotherapy, environmental immunotherapy. So allergy shots for like grasses and dogs and cats. They used Xolair on top of that to make that program safer. And they saw that it was safer.
So this was something that you saw, hey, it's working in environmental, let's bring it over here.
Exactly. Dale Umetsu thought of it, and he was my mentor at the time, and I was his fellow, so we wrote the first protocol together.
And this was 2003, 2004?
2003, 2004.
Yep.
And Xolair had just gotten published by Donald Leung in the New England Journal, showing that it helped reduce someone's reaction to peanut. So all the dominoes lined up.
Yeah.
And we thought, let's start using this in milk oral immunotherapy.
Now, earlier when we were talking about this, not recording, you had said that at that point, when you decided to propose this research, both Stanford and the FDA took risks.
Yes.
So, ignorant question, when you were ready to do a study, and you were going to do a study, I guess, with OIT and Xolair, I guess Stanford, through its institutional review board, would have to approve that study.
Absolutely.
Does the FDA itself also have to approve?
Yes.
That's a lot, because they got a lot going on improving drugs. I didn't know that they approved research, like preliminary pre-phase 1 research.
Absolutely. If you want to do a human trial of any sort, you have to go through the FDA. And so luckily, there were people in the FDA that understood the need, that also agreed with me that it has to be done extremely safely, so to go slowly, to not do anything that could cause allergies. We wanted to be very ethical. Plus, we were doing this in children, so we wanted to be super careful. And I don't like to do anything without doing my homework first and double-checking and triple-checking everything. So we had the data coming out of Genentech and Tanux that showed that by giving anti-IgE, it could really decrease your allergic reactions. So we thought that was terrific. And we showed that to the FDA and our IRB.
Institutional Review Board, which is at Stanford. Yeah.
So this thinking behind Xolair and milk wasn't totally out of the ordinary. We wanted to make sure, though, that people understood why we wanted to do it the way we wanted to do it, which is give Xolair in the beginning and then start dosing up milk and then have milk be dosed enough so that people could feel protected for eating a pizza. So that was the special uniqueness of it. We got that approved, thankfully, the FDA as well as the IRB. We enrolled about 11 patients and we saw great results. Not everyone was able to get up to a high amount of milk, but everyone was able to go up to higher amounts of milk.
And so you saw them rocketing through the oral immunotherapy protocol faster and getting to higher levels.
Exactly, without any safety risks. So because of that, then we broke open the paradigm and said, all right, let's do this in peanut and break open the paradigm even more, and let's do it in multi-therapy.
Which had not been done at all, if I'm not mistaken, for OIT at all. People were not doing multi-therapy.
That's right. And I think people
multi-food therapy
were worried in that same kind of precautionary reflex that strikes our field. People just thought, that is way too complex. And if you do multi, if you put all these proteins on these bad actor cells, basophils, mast cells, you could just overblow the system exponentially.
Yeah.
Well, what I did is I took patients' blood that actually were multi-allergic and I incubated them ex vivo in the culture dish with X, Y, and Z to make sure they didn't have exponential responses. I could measure the histamine. I could measure the interleukins. And I wanted to make sure that they weren't exponentially increased when you exposed X, Y, plus Z.
Yeah.
Instead of X, then Y, then Z.
Which is important because you said 30% of people have a food allergy or multiple allergy. And so if you created something that would just work with milk or work with lone allergies, you'd be leaving a third of the most needy population out of your therapy.
That's right. And it wasn't until in 2009 when I had to give grand rounds here at Stanford and a mother, Kim Grosso, came up to me and she goes, enough about peanuts. You need to help my child. She's allergic to shellfish sesame, cashew, egg, milk. Like, she can hardly eat anything that is part of a normal diet.
So this was a mother who came up to you when you were working on this, and so that drove you to multi.
And then I thought, okay, then this has to be the next impact. We need to incrementally improve this field, because if we just keep on using one food allergen at a time, we're never going to get there fast enough. So then I just thought, a protein's a protein. The body sees anything that it eats, it breaks it down as proteins. It doesn't know that that came from a peanut or, right? It just breaks open proteins. A peanut protein gets digested into 333 different peptides. So then I kept thinking about it and thinking, fine, let's do this as a multiple allergic desensitization procedure, but make sure the doses are very low so that we don't induce any major safety issues. So then we published our phase 1 data. But that was very hard to publish. That took 2.5 years to convince people that we had done it.
There was a lot of time in the wilderness, and I want to just go over that briefly because I know there was a span of time when you were really struggling with funding. We're talking about connecting to the community earlier. A lot of parents of allergic children in the Bay Area, you knew them, they'd found out about you, and they funded you, right? I mean, it was a community, or at least partially a community funding thing, right?
I was very grateful that you can't pay to get into clinical trials at all. Like, all clinical trials are free to anyone who participates, and you always have choices because we want to do them very ethically. But when we were running our clinical trials, it was very hard to get funding from any national organization. FAIR was actually one of the few places that gave us funding after our first phase 1 trial.
FAIR, and remind us what it stands for.
Food Allergy Research and Education.
So this is a national organization that raises money for funding and also does lobbying and so forth, right?
Exactly. And we're really grateful that FAIR and their Research Advisory Board took the risk with us to be able to do clinical studies in multiple foods, and they funded in part one of our phase 1 trials with Xolair.
And then this hard to publish thing, that's crazy, right?
Yeah, our study was rejected 6 times.
The paper was?
The paper.
Wow.
In my lifetime, I think perseverance is key and tenacity is key. And most importantly is that we dedicate ourselves to the data and its authenticity and making sure that it's accurate. So finally, we did get it published. We're very grateful, presented at some national meetings like the Canadian Society, and they understood it right away. There were people that got it and took it up, and really the next question was, all right, now let's do a randomized controlled trial. Let's do a phase 2. And so I was very grateful that at that point, the NIH funded the phase 2.
So in comes the NIH. What year is this now?
This is now 2015. We got our NIH-funded study.
Great.
And so it took a lot of wonderful philanthropists to back us so that we could get there. Philanthropy and nonprofit organizations really are the bed of nutrition for researchers like myself to be able to take those risks over the 5 years that it takes to build up the research data enough so that you can apply to an NIH grant and then build it from there.
And you were backed by other philanthropists, including Jeff Bezos, if I'm not correct.
Jeff Bezos,
I'm not mistaken,
and
rather.
Mackenzie Bezos had put in their private funds to match one of the phase 2 trials throughout the country. We're very grateful for that, and a lot of other philanthropists as well.
And let's talk briefly about the results of the phase 2.
So we've had 2 phase 2 studies that have been published. We had great results. The majority of the people with multiple food allergies did great, and they were able to get up to 2 grams within 9 months. 2 grams is basically equivalent to a tablespoon of peanut butter.
And so if you're at 2 grams of tolerance, you're essentially safe from somebody putting peanuts into your chili without you knowing it. All of a sudden, this realm of terror, you're fine at 2 grams. It's just not. Yeah,
exactly. 2 grams of shrimp, 2 grams of egg, 2 grams of milk, that is a lower amount accordingly. So 2 grams of an egg might be eventually 1/4 of a whole egg. So we wanted to, for some patients, even go up higher.
For different allergens, yeah.
We were able to with that as well. So we gave Xolair in the beginning, and then we ramped up the dose quickly under that cover of Xolair. Then we got up to maintenance much
So you
faster.
inject them once with the Xolair, and that kind of gives them some coverage for a span of time.
Right. You give them about 3 doses of Xolair through about 3 months worth, or 6 doses or 3 months worth of Xolair. And then you start dosing up here, get it up high, and then you continue that maintenance. Now, there were still people with symptoms, but by getting them up high, they were able to go to a food challenge and meet that food challenge. And now a lot of those people are doing very well.
Now you are very much out of the woods. You have this fabulous center. Mr. Parker came in with a generous donation. You're getting NIH grants. Where do we go from here? Biomarkers, you mentioned them. Is it conceivable you'd find something in a person's blood that would mean you don't have to do a food challenge?
We do have some biomarkers, not perfect, but we're getting there. And so over the past 5 years, lots of researchers are coming out with what can we manipulate in the blood, in the saliva, that could predict someone's food allergy or can predict someone getting better in food allergy therapy. There's nothing on and available in the clinic yet. Thermo Fisher has component testing. We have biomarkers for IgE for different foods. We have IgG4 that people can actually get tested for in their blood that is somewhat protective. And then in addition, we have the basophil activation test, which in Europe is actually an approved laboratory procedure that one can actually get insurance coverage for.
Now, this is like a microfluidics lab on a chip type of thing, right?
So there's the specific IgE, there's specific IgG4, and then there's the basophil activation test. All of that can be put into potentially a diagnostic chip with all of those markers. There's chips being developed now in Austria, in Vienna. We're developing a chip now with microfluidics so that all you need is 2 drops of blood.
Here at Stanford.
Exactly. And we will look at IgG4, IgE, basophil activation all at the same time.
You said 96 different, I think, when I saw you speak once.
That's right. So we're looking at 96 different allergens now that you can do on a microfluidic bed in a diagnostic chip.
Which would be a very, very robust test.
Which would be fantastic. And when you look at biomarkers, you have to be really careful in that any one biomarker might not be suitable to diagnose all the population. So you think of a composite of biomarkers that together, if they're all positive, then you can say, all right, you have a 99.9% chance of having that food allergy or that drug allergy or that environmental allergy. So I think using the multiplicity of the biomarkers that we now have to be able to get them out to the laboratories and get them CLIA approved for insurance reimbursement is key. There's nothing that's outside of the specific Ig and the specific IG4 that's CLIA approved yet or clinical laboratory approved, but we're getting there. We've published and other labs have published that if you use this basophil assay, this biomarker, and you use it with clinical history, you can predict who's going to have a severe reaction or not. Within all of that, we are getting to a stage where hopefully biomarkers will supplant food challenges. I think even now we have enough data that's been published to be able to remove 50% of the food challenges that are done today.
In the broader population, for that person who's about to have their 501st shrimp cocktail
yes.
and have a horrifying reaction to it, it could be part of general health monitoring, maybe even part of like an annual physical.
Exactly. And in the era of personalized medicine, when you can take your smartphone and put a chip into it and determine if you're allergic to X, Y, or Z, this is what people deserve. We need to make sure that people don't overdo a test, but if the test is accurate, this is the era of personalized medicine. We should be aiming towards that, not having to have people go through draconian food challenges and risk their life in a doctor's office nevertheless, but still, it's nerve-wracking. And even now, there have been publications coming out of Boston, Andrew McGinnity and Linda Schneider, as well as our group, showing there's enough data in skin prick tests and IgE tests that you can know if you need to do a food challenge or not for certain foods. So we're 50% there, but now we need to get to 100%.
It sounds like oral immunotherapy, lo and behold, after 100 years of experimenting with it, it actually works.
Yeah.
But it also takes a year or more to build up this tolerance. What is the potential to not only do away with food challenges, but to do away with OIT, like have a vaccine or something like that? What's the nirvana point?
Yes, exactly. Where's our moonshot in food allergy research? I think it's great that we've accomplished so much in relatively short amounts of time, using some principles that were used in allergy immunotherapy for centuries for other proteins. Now, fast forward, we have other allergies now coming up like alpha-gal, allergies to sugar. We have people that are getting more severe. We have multiple food allergies. So we're going to have to keep adapting. In oral immunotherapy, I think it has a lot of hope and promise. SLIT and EPIT also does. But then when you think, what are our moonshots? When Sean initially came to me, Sean Parker, he said, I want you to get rid of allergies within 2 days. That's it.
Like cure somebody of them.
Cure in 2 days.
Yeah.
I said, all right, we got a lot to work on. We'll try to get there, but at least along the way, we're going to mitigate disease and we're going to find out new technologies to be able to do that. So then fast forward about 5 years now, here we are in 2019, and there are vaccines out as gene therapy products that have just been tested in adults and they've been found to be safe. So they're moving forward with in teens.
Vaccines to prevent
for
peanut
allergy.
Really? Did some of that work go on here?
to treat. And yes, we were one of the sites for the trial. It's a company by the name of Astellas. But importantly is that if someone wants to look at all the clinical trials that are going on in food allergy, they can get there via the clinicaltrials.gov site in the U.S., which is great. It's a great reference for people to be able to see that, wow, there's a lot of things being developed in this field now. Vaccines being one of them. There's another vaccine company called Aravax in Australia that are doing peptide-based vaccines to try to protect your immune system and create tolerance to peanuts.
Create tolerance without having to go through the whole OIT thing.
Exactly, just shots.
Yeah.
So I do believe it's going to be possible. Is it possible for every individual to use the vaccine? I don't know yet. But I do know that people are taking shots at that moon.
Mm-hmm. No pun intended.
Exactly.
Yeah.
So I think these vaccines are really exciting. I think that adjunctive therapy with biologics is really going to make a difference.
Define a biologic for those who don't know.
Sure. So a biologic is using like a monoclonal antibody or an interleukin or a product that's a protein.
It's a natural product of the body or of
product of the body to be able to use with your oral immunotherapy to decrease side effects like the dupilumab or the Xolair.
So it'd be like a Xolair.
IL-33, that's right.
Of all the things that are going on in your center now with the 60-ish people who are doing research and bioinformatics and all the other stuff, are there one or two things that you find especially exciting and promising?
I'm really excited about this quandary that I have, especially going back to the twins' work, where what are the active states of protection that someone has who does not have food allergy? What allows someone to lose their food allergies naturally? What does their immune system do? Because somehow by naturally becoming tolerant and losing your food allergies, or for people that don't have food allergies at all, there's an active state of protection. What's going on in the immune system? So we've made some key discoveries in a novel immune cell to be able to understand what is that active protection, and most importantly is how do we induce it for the people that have the allergies. And so I think it will have wide implications, not just for food allergy, but for other allergies
for
too.
Environmental and bee stings and things like that too.
Absolutely, because all they
kill so many people,
that kill a lot of people, that have a high rate of having to use emergency services and have a ripple effect through society. So with that in mind, trying to understand what actively protects someone from having an allergy in the first place. If 1/3 of people get allergies at some point in their life, what are the other 2/3 doing to not allow that to happen? So that's, to me, really exciting.
That is exciting.
The other part that I'm really excited about is how do we make anything safer? How do we make sure that we can understand our science so that when we give therapy, it is a safer therapy and that it lasts permanently?
Has anybody ever died from oral immunotherapy?
It's a great question. We want to prevent that, and that's why we use very well-trained people, not just at our site, but many sites throughout the country.
How many OIT clinics would you guesstimate there are throughout the U.S. at this point?
From what I understand, the outpatient clinics that are private, there's about 100 plus.
100 plus throughout the U.S. So if you live in a city that's got an NFL team, there probably is one, but if you live in a remote place, there probably isn't one.
Right. So you need access. People need access. The underserved, the people that don't have health insurance, they are the ones at highest risk for developing allergies. They need care. But the institutions that are doing research, oftentimes the NIH is working with them through this cooperative food allergy research organization, and that is called COFAR. And so we're really glad about having a consortium that we can work together with. But there are many institutions now throughout the country that do food allergy research trials, over 100.
Oh, really?
So that's great. And that's where a lot of these companies can then try their new products out.
And there is a lot of startup activity. And that's one thing that didn't exist 10 years ago, right? I mean, I was at an event that you spoke at in Menlo Park a few weeks ago, and I think you'd said there, maybe even at that event, there were people from 14 different startups that were in some way connected to this.
And it's terrific that now there's a way. The FDA has worked really hard to create doable endpoints for clinical trials. They've created guidelines for companies to be able to get approval. So the FDA really has taken this very far, and I'm appreciative of that. And they've gotten educated themselves quickly on preclinical, clinical, phase 1, phase 2, phase 3, and then they've helped us tremendously to be able to get a licensed facility together. But importantly is when you think about what has to happen for the future, when you think about how do you create that moonshot, having patients come into clinical trials, making sure that people know that there's a safe place, that everyone should get access to clinical trials, that by being in a clinical trial, people can get a lot of care and people are incredible pioneers and they create a legacy for others. But in addition, by being in a clinical trial, they're part of a family unit and to be able to think about what you're providing for the future. So there are a lot of unanswered questions. A lot of pioneers have come before and they've been very courageous, and I'm thankful for that. No one has anaphylaxed and passed away due to any oral immunotherapy in the United States.
That's great. That's great.
Under clinical research, there was one case in Japan when they were doing rush milk immunotherapy in the hospital, and the patient unfortunately passed away because the dose was too high.
Even with all that infrastructure around them. Just out of curiosity, have any of your children had food allergies?
Well, I have to say that when the guidelines came out in 2000, I didn't pay attention to them at all.
The guidelines that told you not to expose.
Exactly.
That's a good thing.
I probably did the opposite because I didn't have much time and they had to eat whatever we were getting fed because I didn't have much time. I was a working fellow.
So your kids were young right at the time where the government was screaming at them to not have any allergens until they were 3. And you skated through that. That's great.
So I am to blame for their lack of many things, but their lack of allergies, hopefully they'll be happy about. Yes, I'm excited to be a mom and a pediatrician and to have 5 kids with a partner who otherwise I would never be able to do anything without him. So I'm very grateful. And yes, I've learned a lot and been very humbled by, as children grow up into adults, how we can protect them. And I think as parents, we want to make sure that our kids can live in a world that's safe. And as adults, we want to make sure we live in a world that's safe. And so for the part that I can do with understanding allergies, especially food allergies, and work with other organizations to create ways to prevent and cure, I'm excited about this for the rest of my life.
Well, it is amazing momentum. I mean, the center is vast and gorgeous and has lots and lots of work going on. I know a thing or two about FAIR, that organization that you mentioned. Extremely well led, I'm going to say. I'm a little biased because I know the person who leads it and I'm a big fan of hers. But it feels like there's a lot of infrastructure, a lot of funding, and a very bright future for this field.
I'm really excited. I think that we still have a long way to go. We've worked really hard to get where we are, and by that I mean the whole field, and a lot of very dedicated investigators and dedicated patients and families, and FAIR and EAT and other nonprofits. They're all part of that, and we need to have discourse with advocates on the Hill, advocates at the FDA, advocates everywhere in the community. So anyone that has any questions or that wants to reach out, we are happy to have any questions about food allergy and to try to help the community. Our website has a registration where you can actually register to be on our list, get our newsletters, as well as to get other activities that's going on for education and our clinical trials. We try to notify people right away when they can get into a clinical trial, so we want to give people hope and promise for any food allergy. And then lastly, we also feel like there's an incredible connection with nonprofit organizations like FAIR, like EAT. And so to visit their websites and to be able to see what are the educational products as well as links that go on in the food allergy field. And I would encourage everyone to go on the blog sites, look at what's being said out there for food allergy and how we can understand this disease better. And I'm very grateful for you and the media for trying to understand this too. I've known a lot of great journalists and radio hosts then looking at other ways to get the word out. Thank you.
Thank you. Well, thank you for being so generous with your time this afternoon, and thank you for all the amazing work you're doing. It really is extraordinary.
Thank you.
All right. We'll now spend 2-ish minutes with Andrew Beebe of Obvious Ventures talking some more about flying cars. Then I'll be back to tell you about what's coming up next on the podcast, about something really cool I have this week for the folks who support it on patreon.com, and more. So back to the New York example. If you're going to fly people from Manhattan to the airports for the cost of an Uber rather than the cost of a helicopter, you're talking about an 80-85% price drop. What's going to make that possible?
What's enabling this transformation really is drones. Drones, because of the mass scale of production, have really changed our ability to integrate energy storage software and sensors into flight.
Let's talk a little bit about energy storage.
We can now use an individual Tesla battery, literally just a car battery, to fly people from San Francisco to San Jose. When it comes to sensors, I mean, thank goodness for the iPhone, right? These devices have made all of these critical sensors in avionics like GPS and accelerometers almost free for flight vehicles today.
Okay, so that's batteries and sensors. The third thing you mentioned was software. What's up with that?
The software that's come out of the drone industry has solved a lot of problems that we can translate into human flight. Like, can these vehicles hover correctly and stabilize despite windy conditions? These are actually technically very complex issues, and they couldn't be solved without great software that's come from the drone industry.
What's the competitive state in the industry?
We are definitely in the primordial ooze phase. This is a little bit like, say, the Democratic presidential primary contest today, where everything is coming out of the woodwork and something very interesting is going to emerge. There are probably a dozen real contenders, and some of them have excellent Fortune 500 backing from companies like Boeing and Airbus and Alphabet, Embraer. And there are also a lot of great startups like Lilium, where we have an investment, and Joby and others. People are doing autonomous test flights. A few of them have done manned test flights.
What are some second-order effects in industries or markets that could be transformed by the rise of this new niche of transportation?
I think electric flight is going to transform housing. In major cities around the world, we're seeing a lot of affordability challenges, and the ability to transform a 3-hour drive for commuting from way outside of the city, converting that to 30 minutes in flight would really change the way we think about housing.
So, huge thanks to Obvious Ventures and also, of course, to Dr. Kari Nadeau for that profoundly in-depth interview. If you'd like to hear all about this from the other side, from the standpoint of a food allergy patient, you can join me on Patreon this week, or in your podcasting app if you're subscribing to my Patreon feed. I'm presenting a terrific interview with one of Kari's former patients. His name is Matt Friend. He's a student at NYU, and he used to be deeply allergic to wheat, rye, barley, and oats, until Kari and her team got their hands on him. Matt tells us all about living with this formerly frightening condition and the treatments he and his family turned to defeat it, including oral immunotherapy. This is part of the continuing series of extra material I make available to the folks who sponsor this show at a level of $5 per month or more at patreon.com. That's patreon.com/Rob Reid, and Reid is spelled R-E-I-D. I'm continuing with my Patreon program despite having my first sponsor for a couple of reasons. The first is that I'm developing a fairly exotic and handcrafted form of sponsorship here. It took 1.5 years to find my first sponsor, and it could well take that long to find the next one. Who knows? So I remain deeply grateful to my community of supporters, which I will continue to nurture as much as I'm able. The other reason is I just really enjoy creating this bonus material for those who want to dive deeper into the themes of this show. It's a forum for exploring things that may not interest my more casual listeners, and I really like the community of 1,000+ supporters, which is growing up around it. Speaking of diving deeper, in today's show notes on my website, which you can find at after-on.com, I've included links to Kari's center at Stanford, also known as the Sean Parker Center for Allergy and Asthma Research, as well as a link to the advocacy organization called FAIR, which stands for Food Allergy Research and Education. Actually, FAIR's site is pretty easy to find on your own. It's at foodallergy.org, whereas Kari's URL is a bit of a mouthful, so consider dropping by my site for that. While there, you may want to sign up for my newsletter. Do this, and I promise not to abuse your inbox. I only push out notices that are all but certain to interest listeners to this show, like I sent out 5 emails in all of 2018. So join up, and it will be all concise news and no spam. Coming up later this month in the main feed of the show, Berkeley AI professor Stuart Russell. Stuart quite literally wrote the book on artificial intelligence, and that over 1,000 universities use the textbook he co-authored to teach the foundations of AI programming to computer science students. As you have heard me say before, Stuart and the broader AI community have not created a monster yet. But Stuart is deeply concerned about the long-term risks that AI could pose to humanity, and we'll discuss those concerns in our next episode. I hope you'll join us.